Hello, testing, testing. It's Arpit. Hello. Late. I am a bit late today. First, I was streaming to the wrong stream setting. Hi, no condom Chris. Hello. Okay. Think I'm ready. Hello. Good morning. Or afternoon, evening, wherever you are. Mr. Famous. I am not famous at all. We're doing a hard premium problem today. This is Design Search Autocomplete System. We were actually looking at the solutions to this last stream, and I still don't understand it, I think. So I'm going to try doing it actually. Contest in 7 hours. I'm definitely not going to be awake for that. In 7 hours, that's 6:30 a.m. my time. I will do the weekly one though. Okay, design search autocomplete system. Oh boy. Design a search autocomplete system for a search engine. Users may input a sentence, at least one word, and end with a special character hashtag. You are given a string sentences and an integer array times both the length n, where sentences I is a previously typed sentence, and times I is the corresponding number of times the sentence was typed. For each input character except hashtag, return the top 3 historical hot sentences that have the same prefix as the part of the sentence already typed. Return the top 3 historical hot sentences that have the same prefix as the part of the sentence already typed. Here are the specific rules. The hot degree for a sentence is defined as the number of times a user typed the exactly same sentence before. Can you guys see this? By the way, I can make it bigger. Maybe that's a little too big. Okay. The return top 3 hot sentences should be sorted by hot degree. The first is the hottest one. If several sentences have the same hot degree, use ASCII code order. Smaller one appears first. If less than 3 hot sentences exist, return as many as you can. When the input is a special character, meaning hashtag, it means the sentence ends, and in this case, you need to return an empty list. Implement the autocomplete system class. So there is a constructor which takes in sentences and times, initializes the object with sentences and times arrays. Ooh, okay. And then there's input. This indicates that the user types the character C, returns an empty array that if C is equal to enter or hashtag, and stores the inputted sentence in the systems. Okay, so hashtag is the equivalent of like the enter key when I guess you type it into the Google search bar and you actually press enter. So that stores it as the actual sentence that was searched. Returns the top 3 historical hot sentences that have the same prefix as the part of the sentence already typed. If there are fewer than 3 matches, return them all. I see. This is a hard problem. I will probably have to resort to peeking at the solution sometime. Also, I just realized I can't draw here. Oh no, because the Chrome extension doesn't work on Microsoft Edge that I usually use to draw. I'm on my brother's premium account, so that's the only reason I can access this problem. It's a premium problem. Apparently this problem is asked at Roblox a lot, and Google. What's the highest count here? Pinterest? Alright. Okay. This is a try problem, right? I mean, we looked at this solution in the beginning of this week. This is a try problem. Okay. Let's focus on... Should we focus on the constructor part? Should we plan out how we do the constructor? Well, obviously this is a try problem, right? We're gonna have to have some sort of node class. Just gonna make this all comments. Yeah, I can't draw today, so I'm just gonna do comments. We're probably gonna do some sort of node class. Really? Comments don't work like this? Python inline comments multi-line comments. Oh, it's the triple one quotation. There we go. Okay, so what's in a try class? Usually in a try, so a try is like a tree of characters. So if you have like, for example, the word cat, your first node will be a C, and then its children will be an A, and that node's children will be a T. And then if you have another word like cab, you're still going to use the second node A, and then its children will additionally have a B node in it. So yeah, tree of characters to store our sentences, I suppose. So usually a try node has a value in it, and then it has a children. Usually this is like the letter or character mapped to another node representing the character. Yeah. So we have to store like the prefix count of each sentence, right? Return the top 3 historical hot sentences that have the same prefix as part of the sentence already typed. 3 historical hot sentences that have the same prefix as the part of the sentence already typed. Should we store like another... I totally forgot how this is done, even though I literally looked at the solution earlier this week. What if we had a sentence here, and then we just had a count of how many times that sentence appeared. Deepak says, hi, hello, how are you doing? I'm doing a hard premium problem today. Let's say maybe every time we like enter... It kind of sucks I can't draw here. Let's say we have the words like cat and then cab, right? So if I type CA, I should get back like cat and cab, right? Can we test that this works? So our tree node is going to have like a C and then an A, and there's a T and then a B over here. So according to our model right now, so sure, these would be the values of the nodes. Children, sure, these are the ones at the bottom are its children. So let's say I enter cat in it, right? Should I, like at A, should I have sentences like cat and then cab? Should I do this, like a list of sentences? This may be a list. And then C also has a list of just sentences that come this way, maybe? That sounds like a lot of storage though. And then T is just a cat. B is just a cab. I don't know, that sounds like a lot of storage. Is that the right way to go? CA, so when they type CA, they can look into the list stored here. So this is like a list of sentences. I don't know, this feels like a ton of storage. We're storing so much text at each node. But it kind of works, you know? Okay, so what happens when we add another word in, like I don't know, can? So we would go down these nodes, we start at the root, and we're like, okay, C. When we type C, we're like, okay, can was here, can is here, and then we have a end node, and we're like, okay, can ends here. Okay, if I can't get this in 10 minutes, I'll take a peek at the solutions again, but initializes the object with sentences and times array. We probably need a way to just put a word straight into the try, huh? I mean, we did that in the try problem last time. We did like C, does C exist? If not, create the node. Current node is now C. Get its children, does A exist in the children of C? It does, then continue. If it doesn't, then create it, and so on. And then in times. Oh wait, we have to store the ranking, huh? The number of times. Do we have to store like, let's say cat was inputted 2 times, maybe store cat like that? Oh, that sounds like such a hassle. Wait, but if I type CA, like CA all the way here, I I would have to iterate even more down to see that cat appear 2 times. This is such a hassle. What if outside we have a... What if outside we just had a... What if we stored like this sentences to counts dictionary in a, like outside. So cat would be mapped to like 2 here, cab would be mapped to 1, can would be mapped to 1. So we don't need to store the counts over here. Okay, that's a bit more efficient. So if we type C, we would look up cat, cab, and can in our dictionary here. Oh, and then we can sort them really easily by putting them all into a tuple where the first element is their hotness score, comma, the actual word, and then sort those tuples. And then that would give us the words sorted by ranking first and then by alphabetical order. Okay. I still don't like how we're storing sentences at every single node though. But then if we don't do this, we have to like iterate downwards all the way to the leaf nodes. That sounds not great either. Maybe a bit more storage is okay for efficiency. Because then if we get to a node, right, and we have to iterate downwards to see what all of the possible complete sentences are starting from here. What is trie time complexity? Well, to just search if a word is in the trie, that's log n time, right? The tree, every time you go a layer down the tree, you cut the nodes down, like you divide the number of nodes down by a lot. What is n? N is the number of nodes, the number of characters. Yeah, the number of nodes in the tree, I guess. But I'm kind of worried, like, I don't like how we're storing so many sentences per node. But if we were, for example, if you just typed in C, right? And this is your entire tree, worst case it's O of n time if you want to iterate downwards and try to find what all of your words are and be like, okay, these are what we're auto-completing with. Yeah, but n should be something from your input, right? Oh, from your input. Sentences. I guess number of unique letters. No, number of characters total in all your sentences, right? Assuming your sentences are unique. Number of characters in your unique sentences. Well, no, because some of the sentences will use all the same nodes, right? Or mostly the same nodes. I guess, yeah, maybe just the number of unique characters in the sentences. Or basically just the number of nodes in the trie formed by putting all these sentences in. Okay. Quantum Chris says what? Wait, that is right? The number of nodes in a trie is equal to number of characters in the sentences that you're putting in. Number of unique characters in the sentences? Actually, no, I don't think that's true either. Wait, yeah, no, that's definitely not true. You can't just have 26, right? Because cat, cab, can. 1, 2, 3, 4, 5. Wait, that's kind of true here. But then if you have like another knack or something. You know what? Sure, maybe we'll say it's the number of characters in your sentences. It usually will expand per number of characters in your sentences. Wait, let's go through another example here. What if you had like cap? So you would, your current node would be like C here. Wait, you don't even know what the complete word is. There's no way you can even make these things, right? Dang it. Like if I'm at C over here, I don't even know that the complete word is cap, right? Because they feed it to us one character at a time in the function calls. And then a hashtag. So all we can do is say, okay, the current character is, dang it, okay. So we definitely can't do this. We probably can only store the sentences at the leaf nodes. TP Gaming says, hello. Hi, how you doing? C A. Okay, so all we can do so far when we're inputting CA is just make sure the nodes exist, right? And then create them if they don't exist. And then when we get to P, we're like, oh, A does not contain a P. So we're like, okay, P is here. And then we have a hashtag now. So we're like, oh, okay, this is a complete word, cap. And then we can input like, okay, a cap count is 1. Fine, what about you? I'm doing good actually. My work is actually moving offices. We're downsizing. However, there is some upsides. The new office location has a free gym in it. Fortunate guy says, hello, I'm back. Oh, hello, I was just chatting with you on Discord. How are you doing? Okay, so the question still remains, what happens if we're inputting like C over here? How do we know to return cat, cab, can, and cap? Like really easily, without like doing O of n time going down here. I remember in the solutions, because we took a peek at it on Monday, there was a way you can like get all these really quickly, right? But I totally don't remember the method. Wait, let's read this again. What happens if you type a character? Returns the top 3 historical hot sentences that have the same prefix as the part of the sentence already typed. So if you type I, it returns, I love you, island, I love a Leetcode. Yeah, oh dang, it's already 45. Okay, I did say if I can't get it in 10 minutes, I will start looking at the answers. There we go, or else I'll be here forever. Okay, so here are the answers. Yes, you do use a trie, which is a tree of characters. Okay, so here's a trie node. It has a children, I'm assuming characters to nodes, and then sentences. Oh, sentences, which is a dictionary. Okay. The additional sentences attribute will be used to count the number of times each sentence was typed. Okay. Let's start by defining a method add to trie that takes a string sentence and an integer count. Okay, counting add to trie count means that sentence was typed count times, and we will update our trie to reflect that. Okay, so I imagine this is going to be used for the constructor too, and whenever the end of new sentences are typed with the hashtag. Because in the constructor they do give us a sentence plus the count, right? So what we do is we start at the root node. Limitless says, Chet, I have a question of Python. Would you mind giving me the solution, please? Like like right now. What do I look like? An answer key? Maybe, if I have time. For C in sentence. So for every character in the sentence, if the character is not in the current node's children, then you make a new trie node for it. Okay. Node is equal to node.children C. Interesting. They don't pass in the value of the trie node. Maybe this is just pseudocode. But this is okay. Well, I came by to say hi. I see you later. Yeah, thanks for stopping by. Okay, and then you set the current node to that node, which may or may not be there initially, and then node.sentence plus equals count. Oh, interesting. Dang, so they are storing. Wait, they are storing the sentence for every single node. So in this example here, they will store like cat. Well, they're storing a dictionary actually for every single node. Am I tripping? For every character in sentence, the current node dot sentence plus equals count. So they're doing this for every single node. So here would be like cat 2. I'm gonna make this example simpler so I don't have to type a lot. And then they have cab 1. A will be the same, right? And then they would have cat 2. And then cab 1. I see. So at every single node that they come to, they can see with like O1 time. Well, reading the list is still O time, but they can get it faster without iterating to the bottom of the leaf nodes. Like what the sentence is with this prefix is. Interesting. So there's kind of no way around it, huh? You kind of have to store like this to make it, I guess, more efficient. At each trie node, we have a hash map. This hash map holds all the sentences that have the current path as prefix. Because we need to return the sentences that have been typed the most, we need to map each sentence to its count. Okay. We can initialize the trie in the constructor with the initial sentences for each sentence I. We call add to trie sentences I times I. Yeah, makes sense. In the future, when we finish a sentence by calling input hash, we can easily add the sentence we have typed by calling add to trie. Oh, that's how they do it. That's how they update this like dictionary for every single character, even if they don't know what the complete sentence is while it's being typed. So basically when you do hash, you do the add to trie. You call the add to trie function. You call the add to trie function, which updates all the dictionary counts. Add to trie. More like update trie with sentence. That's a better name for it. Okay, the input function now. I think I understand how this works for the most part. So if C is equal to hashtag, meaning we've ended a sentence, so we need to store a current sentence as a string, add current sentence as, as a string to the trie using the add to trie function, and then reset our class variables in preparation for the next sentence. So then we have a current sentence and then a current node. I see. So there's no need to store this dictionary outside here, but we do need a current sentence as it's being typed out, so we can input at the end, and then the current node. And then if C is not equal to the hashtag, and it is a child of the current node, first let's add C, the character, to current sentence, and then walk to the node. Now fetch the sentences that have the current sentence as a prefix. Fetch the sentences that have the current sentence as a prefix. Oh. So if you're typing out cab here and you get to A, and you see cat here. Now fetch the sentences that have the current sentence as a prefix. We store them in the hash map current node.sentences with the mapping sentence count. Finally, sort these sentences according to their count and return the top 3 sentences according to the criteria in the problem description. Wait, fetch the sentences that have the current node as a prefix. We store them in the hash map current node.sentences. Is this the one we've already made with the mapping sentence count? So we just get this and sort them, no? Okay, if C is not equal to hash, but C is not a child of the current node, there are no existing sentences. We just add C to the current sentence and return an empty list. Okay, so the hash, I understand the hash case. What happens when they type in... So this is the case where the node doesn't already exist. And then this is the case where the node already exists. Node is equal to current node.return C. Sentences is equal to, yeah, so we get the sentences from the current node's sentence map. Sorted sentence is equal to sorted key is equal to lambda. Oh, this is a notation I do not know. So you plug in the thing that you're sorting, and then the key is equal to lambda x, which returns the item value and then key. And then you get the, for I in range min 3 length of sorted sentences, okay. Answer.append sorted sentences, I 0, where 0 is the sentence. Oh, I see. You know what? I think I understand this now. It's really complicated, but I understand this. I probably will need to do some Googling for the actual fetching and processing of the dictionary too. But I think I understand it. Oh. Okay. This might be pretty painful to implement, but I will do my best. But I guess the important thing to know is that we're basically storing a trie, and at every single node, we're storing the count of each complete sentence that has the current node as part of its prefix. Yeah, that's basically the structure. All right, give me 1 second. Okay, let's start implementing then. So the init part. The init part. So we're gonna have to implement. We're probably gonna have to initialize our first trie node, right? Our root node. Ooh, So we probably need to do a trie class. Class node. We're going to store a value in it. Define in it. We're going to take in self and then a value. And then we're going to do self dot value equal to the value. And then its children is equal to just a empty dictionary for now. Sounds okay. Wait, how did they do this too? Trie. They don't even store a value for the trie node. I think I disagree with that. You should store some sort of value, like the current character of the node, right? Okay, this seems reasonable. So for now, I'm just going to do self.root is equal to self dot, wait, no, just a new node, right? Node. I'm just call this the root. And the children will be empty dictionary, that makes sense. Self dot, we have to store the current sentence. Current sentence that's being typed out is equal to an empty string, and then self.current node. Current node, as we're typing the sentence and as we're traversing the tree, is self.root. Am I allowed to run anything so far to make sure that it actually compiles? Return, let's return like none for now and see if this actually compiles. Okay. It compiles. Test case. Okay. Let's do, oh right, in the constructor, we're given a list of, well, I completely forgot about this. We're given a list of sentences and the times, huh? So we have to initialize that. Okay, for the first test case, I'm just gonna 1, 2, 3, 4. We have 4 inputs. I'm gonna delete all the inputs for now and just have the constructor. Put all this at the bottom here. Okay, for the constructor, yeah, so we need to process all these sentences, huh, and input them into our trie. I think we need to define a function like the solution said, to define add sentence. So it's going to input the actual sentence and then the times. And we're going to do that for every single node. Yeah. Okay, add sentence. We're going to start at the root node. So node is equal to self.root. And then for every single character in sentence, if C is in node.children, that means it's an existing character. Well, not in node.children, this is when we have to take action. That means we have to make the child node and then put it in. So new node is equal to the new node. We'll take in the C character, and then we'll put it into the current node's children. Node.children, the current character is equal to the new node. Okay. And then over here, now at this point, we're guaranteed to have the node in the trie. So what we have to do is node is equal to node.children C. Yeah. Okay. So right now we're iterating from the first character to the last character. Okay. For C in sentence. And then for each node, we have to add the count of the sentence to its sentence counts. Okay. So the current node dot, oh right, we have to make a sentence counts too. Sentence counts is equal to empty dictionary for now. Node dot, I'm going to make this shorter so it's easier to type. Node dot sentence counts for the current sentence is equal to node.sentence counts dot get or default the current sentence. Is it possible in Python to do it like this, like a new line? Python new line, how to split one long line into multiple lines using backslashes, parentheses. I see. Like that. Okay, I think I like this. Okay, so right now we're doing the node, the sentence counts of the current sentence is equal to node.sentenceCounts.get or default the current sentence, the current count or default to 0 plus 1. That is so verbose. Node.sentenceCounts sentence dot get or default sentence comma 0 plus 1. Yeah, okay. Python is an interpreter language, right? So if I want to use this function in the initializer, I have to move this up, right? Okay. Cool. So in the initializer, for every single sentence and its count, we will call add sentence. Yeah, that's it. So for I in range, the length of sentences, add sentence So we will input sentences I, meaning the current sentence, and then times I, the number of times that sentence was searched for in the past. Okay. So right now, my case 2 is just a constructor. So if I run this, hopefully it should compile. Expected total calls made to a value 1 to 5,000 only. Total calls made. What the heck is total calls made? Expected total calls made to have a value from 1 to 5,000 only. Is this literally because I'm calling too many functions too many times? Expected total calls made to have a value from 1 to 5,000 only. Ooh, am I calling too many stuff? Okay, let's walk through what we're doing here. Okay, so self.root is equal to a new node, root, current sentence is equal to empty sentence, self.current node is equal to self.root. For I in range length of sentences, add sentence, lane sentences. That should be right? Add sentence, sentences I, and then times I, add sentence. Okay, and this is add sentence, sentence comma times. Node is equal to self.root. For C in sentence, if C is not in node.children, then new node is equal to node C. Node.children C is equal to new node. We put this new node into the current node's children. And then the current node is equal to node.children C. Node.send counts sentence. Sentence counts of the current sentence is equal to the count of the current sentence, or default 0 plus 1. Why are we calling stuff too many times? Okay, let's do print. Vietnam says, where are you at One Piece currently? Oh, it's really sad actually. I stopped watching One Piece. I got bored after they tried to save Luffy's brother. I was promised that this would be like a very exciting, like Avengers moment, but it was kind of underwhelming for me. And I was already getting kind of bored up till that moment. And that the only thing keeping me going was the promise that this moment was gonna be really cool. And when that moment came and it underwhelmed, I kind of just stopped watching. Yeah. Where are you at? Does it get better at One Piece? Adding character. Processing characters C. And then let's make sure. Let's actually print when we're actually adding a new node. Adding new node for character. Vinan says, yeah, of course, it's sad you quit. Do you think I should continue? Does it get better? Invalid test case. Oh, it's not my code that's wrong. It's literally... Oh. It's the test case that's wrong. Dang it. So for case 2, I'm just going to have one input then. Maybe I just input I, just one input. Add sentence is not defined. Where? Oh, here, add sentence. Oh, do I have to do self.add sentence? Self.add sentence. Oh, I have to do self here too. Right? Is that why? Okay, well, at least it's going in now. Node object has no attribute children. Yeah, it does. Node init. It's right there. Oh, it's not publicly available because I have to do self. Self.sentence counts. You should continue if you have time. Oh. How would you rate like One Piece, like before and after the when they were trying to save Luffy's brother? Is it from a scale of 1 to 10 before and after? Dict object has no attribute get or default. Really? It doesn't? Python, or is it a Java thing I'm thinking about? Get or default? Yeah, for anime recently, I've been watching. You're gonna be so mad when I say this. I've been watching One Punch Man. Oh, I'm such an a-hole. I stopped watching One Piece by I started watching One Punch Man. Cool, it's actually compiling now. Okay, am I inputting stuff correctly? So first is I love you. What, you watching OPM season 3 instead? Yeah. Yeah, it's pretty bad. Did you see that one TikTok? I mean, one short where someone actually counted how many frames they used in like 20 minutes of animation or something, and it was like just 15 frames because it was just all dialogue and it was like a slideshow that was all panning. Yeah, I don't know what's wrong with me. I'm more willing to watch One Punch Man 3 than One Piece. I love you, okay. And then we're doing island because I is already there. Island. Iron Man. Yeah, it was 20 frames in the sliding scene. Oh, I saw that. Wait, yeah, it was so funny. Apparently even AI did a better job of animating the sliding scene. Like his legs actually moved and the grass actually moved too. Wait, I wish I can draw right now, but I can't. They literally just took a PNG of him, of Garo, and then slid him down the grass and nothing else. It's so bad. iRoman, so Roman will be here. Roman, yeah, I think I got it. I love Leetcode. So then only Leetcode will be inputted? Leetcode, yeah, I think I got it. Okay. Cool. So we've instantiated this correctly. Do you think, wait, at this point, do you think they're doing this on purpose? Just like making it so bad that it's like the talk of the town? Like it's so bad that it's getting, like people are actually talking about it. Unlike season 2, I feel like it's actually comically bad. Is the studio just rage baiting us at this point? So they don't lose relevance? They're like, you know, we know we can't beat season 1. Mappa set the bar too high. It's gonna be a disappointment no matter what. Why don't we just rage bait them so we can actually still show up in the algorithm because people are talking about it so much? Did you know this OPM season 3 is directed by a hentai director? No way, I didn't know that. Does this explain why the animation is so bad? Have you seen his other works? I don't watch hentai at all, so I wouldn't know. Have you seen his other works? Is it actually comparable? Okay, so this is good news. The initializer here seems to be working. So now all I have to do is work out how to actually input characters in here. Oh, okay. So C. Let's do the case where... You know what? Let's do the case where C is just a regular character. So if... No, I don't hentai either. Oh. Dang it, I was hoping you'd be an expert in that subject matter. Wait, is that actually true? Who is this guy? Okay, I don't care. One Punch Man Season 3 Director. Can we confirm this? Cool, conspiracy theory. Do you think he's directing One Punch Man 3 horribly so that he can cover up all the internet search history of his hentai work? Because right now, if you search Shinpei Nagi, surely all the Google search results are going to be of his work with One Punch Man, right? Nobody's going to see his hentai stuff anymore. Season 1 was peak. It's disappointing what they did. Yeah, I really enjoyed Season 1. It's honestly one of my favorite shows of all time. Oh. Can we do by most recent? Yeah, One Punch Man 3. Like, it has everything, like good animation, good fight scenes, even like moments that make you cry. I don't know if you remember, one of my favorite moments is when Moomin Rider was fighting the Sea King, and it was like, he knows that he's gonna lose, but, oh dang, wait, this guy has done a lot of good stuff. Banana Fish, JoJo, Psychopath, Dr. Stone. Dang. And you say that he directed hentai? I've heard of Data Light before. I know this series is like super popular. Dang, he's done some really cool work. Yu-Gi-Oh! 7s? What? Nobody complains about animation in these works. And then One Punch Man 3 is his magnum opus at the very bottom. I don't see hentai here. Oh, never mind, I see hentai here. Thank goodness this is not zoomed in. Or I might get demonetized. Well, I'm not even monetized, but okay. Okay, so if self.current node, we have a current node, right? Current node is here. Self.current node. Well, we have to check if the current character is in the children of the current node, right? If C is not in self.current node dot children, and yeah, that's it, right? What am I hesitating for? Dot children. Then you would just return. Well, you would still need to add it in. So self dot current node dot children, the current character is equal to new node where the value is the current character. Not all, but some directors were. Oh, you're not. Okay, you're talking about other directors. Oh, there's multiple directors. It looked like there's just one director. Interesting. Node C. Okay, and then we would return an empty list, right? Because that means we have not traversed this path before. No other sentences have this new node as its prefix. The newest episode has a rating of 1.9. Dang! The worst rated anime episode ever on IMDb. What's the current episode? Have I watched it yet? One Punch Man. Latest episode. Oh. Oh no. 2 days ago? Okay, I have not watched it yet. I don't think I watched One Punch Man yesterday or day before yesterday. Well, I have something to look forward to after this stream that I'm probably going to watch it. Okay, so for case 2 over here, just to test out what I've got, I'm going to just input like an A. That means we should return empty list, right? Okay, let's go. Oh no, current node? Oh right, current node. Hey, looks like Python has its own like search system going on too. Nice, okay, nice. So the case where we input a whole new character works. That's really good. Very nice. Okay, so now we need to take care of the case where C is in our trie. Oh, okay, this is the really annoying part where we have to do some sorting. So then we'll do... We have to move to the current node regardless, right? So self.current node is equal to current node.children C, and then you return nothing. We just run this to make sure it works. Oh, current node.children. What? Self.current node. It's right there. Is equal to name current node is not defined. We're just using it though. Self.current node is equal to, oh, I see, another self here. Self.current node.children C. Nice, okay. Okay, so if it is in C, then we have to do this thing again. Self.current node is equal to self.current node.children C. And then we need to get the actual sentences that have this as its prefix. Ooh, okay. Sentences is equal to so we have to sort them by, we should get them in a tuple, right? Like the score, comma, the sentence. That will make our lives easier for sorting. So sentences is equal to self.current node dot oh wait, it's sentence counts. So self.sentence counts, sentence counts percent counts. Okay. We have to get both the key and value, huh? So the items. We can probably do some sort of list comprehension, right? Like this. Okay, so S for S in s.currentNode.sentence_count.items, right? Python, how to iterate through dictionary.items. I feel like I should memorize this. Items. Using items method. For state, in states and capitals are keys. Oh, here. For state, comma, capital, in states and capitals.items. Okay. So we're going to do, this map is the sentence and its score, right? So for S, comma, rating. So we're going to return the rating and the score. I should probably write this down. Let me get out my notebook. Okay, where are the Python page at? Oh, here. Yeah, this is useful information. We can straight up do .items, state, comma, capital. Okay, so I'm gonna write for k, comma, v in dict.items. This is possible, I guess. Okay, so we're going to put them in a tuple for their rating and the actual sentence. Rating, rating. I'm just going to return sentences for now. Print sentences to make sure that we're even formatting it in the correct format. Okay, so test cases, get rid of that. Let's add another test case. Let's do, actually just I should be enough, right? Input one thing, and then I should give us plenty of things to work with. Plenty of sentences. Run. None of them work, Sasuga. Okay. Is this backwards? Oh, no, it's right, it's right. Rating first, I love you, One Island, Iron Man. I love Leetcode. Cool. Yeah, this works. And now what we have to do is sort this. Sentences.sort. Wait, how do you sort with a specific key in Python? Python, how to sort with specific key. I probably have to write this down too. by second element. The solutions use the lambda, right? Is a lambda a viable option? Sorting dictionaries by... So you can do sorted. How to sort in place with lambda key. Maybe not in place. Sorting with the sort method. So this is your list. Dot sort key is equal to... Oh, okay. I should probably write this down too. Let me just make sure it works. Sentences.sort lambda the sentence. How do you define a lambda? So the variables, semicolon, that, okay. Wait, I could just... I already made it in the format that I want to sort by, right? Let's just see what happens if I just do dot sort like this. I can't tell because everything is just one. Okay, let's mess with our test cases a bit. Wait, this is wrong. My constructor is wrong. Why is everything just one? It's plus count. Oh, plus times. Nice, okay. 2, 2, 3, 5. Can I mess with the test cases again? What if we do the second one? The last one I love Leetcode is 6. Nice, okay. Cool, that solves our problem. Can I sort stuff backwards? No, it's fine for now. Okay, so all we have to do is now get the last 3 stuff and then put them in a list. So for I in range, length of sentences, but less than -1 or greater than -1, and then we go backwards. Okay, let's set result. Result is equal to empty list for now. And then so we go backwards. Wait, this wouldn't work, would it? Because the rating would be sorted in the correct order if we're going backwards, if we're reading it backwards. But S still wouldn't be sorted. S would be sorted in the backwards order. Okay. I'll still try appending this and printing it out though. Result.append sentences I and then if result, if the length of result is greater than or equal to 3, then you can break from this loop. And then we return result index out of range. Oh no. Result.append I. Really? Range length of sentences. Why? Result.append. Wait, this should be guaranteed to be in range, right? Sentences. Oh. Wait. Length sentences. We're going backwards, right? Python. How to iterate through a list backwards. Range. Oh, -1. Oh, that makes sense. Okay, so we're outputting I love Leetcode, null, and then we're outputting this. So we are outputting 3 things, which is correct. I love Leetcode, I love you, island. Okay, that's a good start. Sentences I. Okay. If several sentences have the same hot degree, use ASCII code order. Smaller one appears first. I want to see how they sorted it in these solutions. What sort of witchcraft did they use for this? Oh, they made the ranking negative, so the bigger ones would appear first. Oh, that's clever. Dang, okay. That makes sense, okay. So you don't even have to go backwards, you can just do length of sentences and then append the results. Hey! 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 They didn't cover all the test cases, did they? We still have to deal with the if C is equal to hashtag, then we simply add the current sentence into the trie. Add sentence, or rather self.add sentence. The current sentence, wait, self.current sentence current sentence, just one, right? Because we typed it in once, and then we have to reset our current sentence. Self.current sentence is equal to an empty string once again, and then current node. I just realized I never updated the current sentence in the current node for the bottom part, so I have to do that too. And then self dot current node is equal to self dot root. Is that how I name the variables? Self dot root, self dot current node. Yeah, okay. So else, no matter what, if it's the two cases here. We need to add the current character to the current sentence. So self dot current sentence plus equals C. And then I have to set the current node. Oh, I do actually. The current node is set correctly. Okay. There's probably some cases I'm missing, but I will just submit it for now. Wrong answer, hooray. Why is it all the way over there? Oh, even the first answer isn't right? Oh, am I actually putting the... Why am I outputting the hash? That's weird. Well, yeah, why are my answers containing the hash? Output. So they input these in. And then they input, what is this? I. Just I love you. So that's right so far, I love you. These are all inputs, so I, and then a space, which is right? And then an A, and then a hash. Oh, am I supposed to return nothing if it's a hash? Return nothing. Wait. What do I do if it's a hash? For each input except hash, return top 3 historical hot sentences. If it's a hash, then I return nothing. Oh, okay. Is that it? Finally. Oh, this problem is nuts. This is a hard problem. We've been here for an hour and 30 minutes, Jesus. And I was looking at the solutions. Oh, mamma mia. Oh, okay. I think I'm gonna end the stream. It took a long time. Oh, by the way, I think my chat was paused the entire time. Thanks for sticking by. I appreciate. I'm gonna end the stream. I'm kind of tired too. And then now? Yeah. I'm gonna sleep like a baby. Maybe I'll watch One Punch Man actually before I go to sleep. Yeah. Okay. That's it for now. Thanks, Vinam, for sticking by. I appreciate. I'm gonna hop up now. Thank you. Bye. newest episode. Yep.